Hey everybody, welcome back. It's the Screencast. It's Maths You Should Know. And today we're going to be talking about adding integers. We're getting ready to transfer to 7th grade next year. And so just to get ready, we're prepping ahead of time, taking a look at what this means. Yesterday we did talk about integers, and integers are numbers that are whole numbers that can't be seen as fractions. They can be negative, they can be positive depending on which side of the number line they are. And today we talked about adding them. We've been adding integers for quite some time. You could say for, well, as long as we've been alive. Here's an example of adding integers, and this should look probably really familiar. 3 plus 3 equals 6. We're used to seeing that anytime we see two integers, especially numbers that are not negative, that are positive numbers, like in this case, positive 3 plus positive 3, that does equal 6. We talked a little bit about additive inverse today, which can be super helpful. Let me do my erasing here. Additive inverse of any number is its opposite on the number line. So it's the equal amount away from 0. So here are some additive inverses in case that sounded confusing. 1 and -1. 3 and -3. 17 and -17. The nice thing about additive inverses, anytime we see them, they can be a shortcut for us. I know on tonight's assignment, there are quite a few problems where additive inverses come into play. Anytime you have an additive inverse, let's just say 1 plus -1, anytime you see an additive inverse, that will always equal 0. So that's kind of handy to know. Additive inverses added together equal 0. We also talked about today in class, when we're adding integers that have the same symbol representation, you just go with whatever the symbol says and add them. I already showed you 3 plus 3. How about 4 plus 2? And that equals 6. Or if I flip the script and say, well, what about -4 plus -2? Put parentheses around that just to keep that in order. Well, you just add. 4 plus 2 is 6. And then since I'm adding two negatives together, it keeps the same sign. So that'll be negative. So that's another thing we learned today. Additive inverses, and also if the symbols are the same. Where it gets a little bit trickier is when the symbols are different. So our third way of adding integers is what happens when the symbols are different. So what if I have, say, -6? I owe someone $6, and then I add 2 to that number. And we talked two ways about looking at this. We talked about looking at this on a number line. So here's the number line. I'll quickly draw. And we'll say here's -1, -2, -3, -4, -5, and a -6. In our equation, -6, we started at -6. And it says to add, which typically means get bigger, which means go, whoop, something just happened. Go that way. In this case, 2 times, because I see a +2. I go boing, boing, and I have -4. All right, here's another way to think of it. We talked about anytime you see the negative symbol and a positive symbol and you're adding, to think of it as a subtraction problem. I'm going to leave this a little messy over here. So in this case, I'm going to think of it as a subtraction problem, but only subtract the absolute values. So in this case, I'm subtracting the absolute value of -6 minus 2. The absolute value of -6 is 6 minus 2, which equals 4. Now, to determine whether or not it's a positive or -4, go back to this step. Which number has the greater absolute value? In this case, it's the 6, and use that symbol. Ladies and gentlemen, that's how to add integers. It's 1, find that additive inverse. If you're adding additive inverses, that equals 0. 2, if the symbols are the same, for example, -4 plus -2, Just add the numbers and use the same symbol. Last but not least, if the symbols are different, like in this case here, -6 plus -2, let's make it a better plus sign. There we go. Plus 2, find the absolute value, subtract them, and then use the symbol whose absolute value is the greatest. Ladies and gentlemen, that's adding integers, and that's today's maths you should know.